Hey there, class. We're here today to learn a little bit about converting numbers from the decimal system into other systems of numeration. So just a real quick reminder that in the past, we've actually done this the other way around, where we've had binary numbers, hexadecimal numbers, and we've actually converted them into the decimal system. But this time we're going to kind of actually work backwards. So I'd like to use this structure here to actually do this. So let's go down and take a look at an example. Our first example here is we're going to take the number 33 and convert it into a binary number. So again, if you think about this structure, the place values that we have in a binary number, this would be an 8-bit number. 8 bits means it has a total of 8 digits in it here. The place values are 128, 64, 32, 16, 8, 4, 2, and 1. And again, if you think about how this works, we almost need to think of this in reverse. So the number I want to get is 33 into a binary number. So if I think about this, I could put a 1 here, but 1 would give me 128. And that would be way too much for this. So I know that I can't have 128. There's nothing in the place value of 128. So I know that has to be a 0. Likewise with the 64s, for the same exact reason. If I had 164, that would give me a total of 64, and that of course is a lot bigger than 34 or 33. Next, in the 32s column or place value, I'm going to need one of those because I know that it has to add up. The numbers in here have to add up to be 33. So I'm going to need a 32. So I'm going to get one place value of 32 is going to give me a total of 32. If I put a 16 in, 16 would add to the 32, and of course that would be bigger than the 33. So I'm going to need 0 of those. Hopefully we can start to see here, if I add 8 to the 32, adding 8 to 32 will certainly give me more than 33, so I'm going to have 0 of them. Adding 4 to 32 will be too much, so I'm going to need 0 of those. Adding even 2 to 32 would give me 34, and that's too much. So I'm going to need 0 of them. The last thing here is I'm going to need 1 in the 1's place value. 1 in this place value will actually give me 1. As I add up all my numbers in this column, 32 plus 1 gives me the 33. So the only thing left to do then is to actually transfer these bits down into something that we might represent as a binary number. So 33 in the decimal system is going to equal, we always write the highest place value first. So this is 0, 0, 1, 0, 0, 0, 0, 1, and that's a base 2 number. So as written as an 8-bit number, this is 8-bit because it has 8 digits in it. This would be the equivalent to 33. All right, in our second example, we're going to take the number 157 and turn it into a binary number. So again, I kind of use my structure here that I've used in the past. What we're going to do is we need to have the numbers add up such that we get 157 down in this place value. So I always want to start in the highest place value. And in this case, I know I'm definitely going to need 128. Okay, because I'm going to add these numbers up, and we'll definitely need 128 to get to 157. Let's take a look here. If I had 128 plus 64, 128 plus 64 gives me 192. So if I used 64, if I had a 64, if I had 1 in the 64th place value, that would already exceed the 157. So I know that I'm going to have a 0 here. Adding 32 to this, let me go over and get my calculator again. If I were to add 128 plus 32, I'm going to get 160. And again, that exceeds the 157. So I know that if I had a 1 in that place value, that would be too much as well. So I know that it's going to have to be a 0. Adding 16 to it certainly is going to be under the 157. So I'm going to need one of those. That's going to give me 16. Here's my calculator. Here it is. So if I add these up, 128 plus 16 gives me 144. One way to do this now is I can take the 157 minus the 144 that it already adds up to, I get 13. So I know that the rest of these numbers have to be used in such a way that it's going to add up to be 13. So I know I'm going to need an 8. I know I'm going to need a 4 because 8 and 4 give me 12. If I use another 2 in the 2's place value, that's going to actually go to 14, and that'll be too much. So I think this is going to work out. I'm going to need 1 8. I'm going to need 1 4. I'm going to need 0 2's, and I'm going to need 1 1. Let's just confirm with a calculator that these do actually add up to be 157. So 128 plus 16 plus 8 plus 4 plus 1 equals 157. So it does in fact work. So all that's left to do now, let me move down and give myself a little more room here, is to write 157 as a binary number. So 157, that's the base 10 number, is equivalent to 1001 1101, and that's a base 2. This is 157 written as a binary number.